Imagine, if you will, a vast green sea. A canopy of ancient trees so thick the sunlight struggles to reach the forest floor. For centuries, this was the world that hid one of humanity's greatest achievements. A city of stone, complete with towering spires carved to look like lotus buds, lay wrapped in the quiet embrace of the Cambodian jungle. When explorers from the West first beheld its scale and intricate beauty, they were left in profound wonder. It seemed impossible, a structure of immense size and delicate artistry, seemingly lost to time, rising from the tangled wilderness, as if a mountain range had been carved by human hands and then forgotten. This place is Angkor Wat. It is far more than a temple. It is a testament to the ambition and ingenuity of the Khmer Empire. To this day, engineers, archaeologists, and historians gather here, drawn by a single persistent question: how? The answers are not in magic or myth, but in a deep, practical understanding of nature. Knowledge that let this masterpiece endure a tropical climate. It is a story of determination against nature, of harnessing floods and droughts, of working with the environment, not against it. Look past the stone and you see simple, clever principles we still learn from today. The sheer scale of Angkor Wat is almost impossible to comprehend. Nearly 200 hectares, the largest religious monument on Earth. A central temple rises in 3-tiered galleries, culminating in 5 iconic towers, 5 to 10 million sandstone blocks, many over 1.5 tons, the weight of a family car. Quarried over 40 kilometers away and transported by ingenious land and water routes. In the 12th century, under Suryavarman II, the aim was not just a temple, but a model of the cosmos. The central towers were Mount Meru, home of the gods. The vast moat represented the cosmic ocean. Every detail, the galleries, the unusual westward orientation, held religious and astronomical meaning. Thousands of artisans shaped structure and story, kilometers of bas-relief turning walls into a stone library. Blocks were dressed so precisely that often no mortar was needed. At the equinox, the sun rises directly over the central tower. They orchestrated a symphony of art, science, and faith, planning, astronomy, and logistics on a humbling scale. The choice of material was fundamental. Sandstone from the Kulin Mountains. Transporting millions of heavy blocks was a logistical nightmare, but the stone was worth it. Properly worked, sandstone is remarkably durable. They created flat, smooth faces that fit directly together, dry-fit masonry, one of the temple's great secrets. With almost no gaps, they denied entry to water, the chief agent of decay. Seepage erodes mortar and invites roots. Tight joints shed it away. Beyond fit, sheer weight added stability. Once placed, a heavy, well-cut stone stays put, bound by gravity. Downward pressure locked lower stones. Weight and friction resisted subtle shifts and tremors. Stone joinery, mortise and tenon, dovetails, gave integrity without iron clamps or modern binders. A simple, elegant solution, using the stone's own properties to ensure endurance, turned the temple into a giant 3-dimensional puzzle built to last. Perhaps the most brilliant feat lies beneath the ground. Built on sandy soil with a high water table, unstable in rain, shrinking in drought. They excavated and backfilled with alternating layers of sand and clay, compacted thoroughly. Sand drains quickly. Compacted clay forms a dense barrier. Together, strong yet flexible. The foundation spread the load and managed groundwater fluctuations. Encircling all is a moat over 190 meters wide. Not decoration, but critical engineering. Kept full year-round, it stabilized the water table beneath the temple. Preventing cycles of swelling and shrinkage, kept foundations level. The moat worked like a giant hydraulic regulator, maintaining equilibrium in the earth. To keep towers pointing skyward, they first controlled the water in the ground. They guided, stored, and used water, creating bypasses so floods flowed around, not through, the sacred precinct. Precisely set gradients kept water moving. No stagnation, no destructive force. They reshaped the landscape into a massive water machine, protecting the temple and feeding a vast society. Beyond the temple, the Khmer water system expanded to breathtaking scale. Enormous reservoirs called barays. Not ponds, but vast rectangles formed by immense earthen dikes. The West Baray stretches about 8 kilometers long and over 2 wide, holding tens of millions of cubic meters. They captured monsoon water and released it through canals and ditches to paddies in the dry season. This enabled multiple rice harvests, a foundation for wealth and population. Agricultural surplus funded temples and sustained urban Angkor. Like the moat for Angkor Wat, barays regulated groundwater across the plain, minimizing subsidence. Anchors of a hydraulic system, balancing the landscape and making a stone city possible. They built for future generations, turning a challenging climate into wealth and power, the barays pumping life through the kingdom's veins. They were the heart of the realm. Water, life, prosperity, allowing the stone temples to flourish on the plains below. For all its brilliance, Angkor Wat was not immune to nature. After the empire's decline, maintenance ceased, canals silted, balance was lost. Seeds found purchase in the tiniest joints. Mosses held moisture. Hair-fine roots probed mortarless seams. Decades turned rootlets into limbs, exerting pressure from within the walls. Even multi-ton blocks yielded to patient growth. At top Rome, colossal roots grip galleries and pry apart doorways. Yet Angkor Wat fared better. Its size, stonework, and moat slowed the jungle's advance. Few footholds for plants. The moat held the deepest jungle at bay. The struggle between temple and forest reminds us, even the greatest creations are part of nature, subject to its cycles of growth and decay. Today, preservation continues, with modern science and technology. International teams work with Cambodian experts to understand and protect this masterpiece. They aim to stabilize without erasing history or compromising original construction. Ground-penetrating radar and LIDAR peer through canopy and soil. They reveal a sprawling, low-density metropolis, rewriting our understanding of Khmer scale and sophistication. Scientists study weathering, pollution, microbes, water absorption, and salt crystallization that flake stone. Engineers document, repair foundations, and reassemble exactly using compatible materials, not harmful cements. A dialogue between past and present. Advanced tools illuminate ancient wisdom in structure and hydraulics. By learning how it was built, we learn how to save it, so its silent walls continue to speak to future generations. Angkor Wat is more than an archaeological site. It is a timeless lesson in engineering. Enduring solutions work in harmony with nature. They turn challenges into strengths, monsoons into storage, gravity into a binder. Decades quarrying, transporting, fitting millions of blocks. Meticulous planning over speed. Getting the small details right saved it. Stable foundations ensured survival. Built with care and foresight lasts. It challenges assumptions. Ancient civilizations practiced practical science born of observation. Its future is not guaranteed. Climate shifts and mass tourism demand dedication and foresight. Protecting Angkor preserves a library of knowledge, a masterpiece of art, a source of inspiration. We honor the builders, ensuring their achievement will awe generations to come. Forbidden engineering? Angkor. What doesn't defy physics? It reveals how well the Khmer understood them. Moats stabilized earth, joints and gravity-bound stone. Barays turned monsoons into power. What seems impossible is patient mastery, art, science, and faith working with nature. If we listen to these stones, they teach us to build for centuries, not seasons. What will we shape together with that wisdom?